What is going on, everybody? Welcome to a part 11 of the Artificial Intelligences in StarCraft II with Python tutorial series. In the last video, we built our neural network convolutional model. And in this tutorial, what we're going to be doing is working on iterating through our data and feeding it through this model. And we should actually begin to train the model in this tutorial. Don't forget, in the previous tutorial, all the training data was linked. Also, the trained model I will also be hosting. I am already hosting it. So again, that's in the text-based version of this tutorial. So with that, let's go ahead and get started. So the first thing we need to iterate through the training data is to iterate through the training data directory. So I'm just going to call that train data because that's what mine looks like. Whoop, try to bring it over. There we go. That's what mine is. So in here is all the data. So when you download it from the training data, just extract it into whatever your working directory is. Okay, so once you've done that, we're ready to start. So the way that we're going to do this is we're going to iterate through. So each one of these files in here is a game that we won, and each game has like 30 to maybe 60 actions that it took that we saved. So each of these is a game. Now, we don't have to load in just one game at a time, and in fact, we really don't want to do that because that would be sometimes a very small batch size that we probably want to load in much more. Plus, we can load in much more, most likely. It depends on your GPU or I guess your RAM if you're not running the GPU version of TensorFlow. So either VRAM or RAM. Regardless, we have more than 4 megabytes, right? So we want to load in a few games at a time. So we're going to do it in like chunks. But we still also probably want to have more than one epoch. Or epic for those that get really angry at me for saying it. So what we want to do is we want to iterate through all of this data many times, but we have to do it in chunks. Now, built into Keras, if you pass your entire data set, you can batch that data, but you still have to have it in memory. So I'm sure in Keras there's a way to do this because this is like a super common problem, right? Your training data is much larger than your VRAM or RAM. So if somebody knows the way, please feel free to link below. The way I'm going to do it is a hacky way around it, but it gets the job done. So I'll move this aside. And we're going to specify HM epochs. We're going to say 10. And now we're just going to iterate over those epochs. So for I in range HM epochs, what do we want to do? Well, we need to track where we are because we want to stop slicing through the data. Again, there's probably a Pythonic answer to this question. I don't know it. I guarantee you one of my viewers knows it, though, so post it below if you've got a sexier solution to this. So then we're going to say increment by 200. So I know you can iterate through something in increments, but that wouldn't stop us. Anyway, it's not important. If you know the answer, put it below. Anyways, then I'm going to say not maximum. Someone's going to just be really bothered by the way I'm doing this, but that's okay. All files equals os.list dir, and we're just going to list out this train data dir. So now that we've got all these files, a thing that would be nice to add in is to not, because we have the opportunity, we don't need to go through the same order of the files every single time, right? We're going to keep loading these in for each epoch. So one thing that we could do is just shuffle them every time we load them in. So first of all, let's grab the maximum. So we're just going to say maximum equals len all files. This way we know when to stop iterating. And then what we're going to do is random.shuffle. And we're going to shuffle all these files. So then what we're going to say is for file in all files. And then we're going to say current to current plus increment. And then what we're going to do is And in fact, let me think about this for a second. So actually, probably what we'd want to do is random shuffle. We'd rather say while not maximum. While not maximum. Then we want to iterate through the files. And as we iterate through the files, we would probably, well, first let's just say print currently doing blank colon blank, and let's format, and then we'll format current and then current plus increment. This way we know where we are in the training. And then for file, for each of the files, what we're going to want to do is we're going to want to take the samples that we have and populate lists that are those actions. So populate lists that are attack enemy base, do nothing, that sort of thing. So what we're going to do is we're going to specify 4 empty lists. So we're going to say no attacks. That's an empty list. And then we're going to say attack closest to nexus. Empty list. Attack enemy structures. That's an empty list. And then attack enemy start. That'll be an empty list as well. And then as we iterate over these files, we're going to just give the full path to that file. Is going to be os.path.join train data directory and whatever the file is. Then data equals np.load the full path. What's that you said? Oh, 2 O's? Got it. So the next thing that we're going to do is data is going to equal list data, because we actually don't need it to be NumPy. We probably could have pickled it or something like that, but right now we want it to be a list. Now what we're going to do is for dn data, we're going to say choice is np.argmax d0, so the 0th. So the 0th was the choice, and then the 1st was the actual image itself. So the choice, and in fact, we didn't really need to argmax this. We could have done this another way, but I feel like it's a little more clear if we do it this way. So if choice equals 0, then we're going to no attacks dot append. We actually should. So in the text-based version of this tutorial, I wrote D0 and then D1. We should be able to just say append D. Right, that was kind of silly. So now I'm going to copy this and paste. Now it's elif. This will be a 1, and I'll fix the other the list in a second. So 1, 2, 3, and then we're just going to go in order. So no attacks. A 1 is a attack closest to the nexus. 2 is attack enemy structures, and then a 3 was attack an enemy start. Okay, once we have that, we've iterated through all of the files in that slice, and we've populated these lists. Now what we want to do is we want to balance these lists. We want them to be the same length as everyone else. So we're going to say lengths. We want to get all the lengths of the lists equals check data. So now we need to build check data. But first, a quick thank you to my recent sponsors, Johannes Geisler, Brock Elmore, Virum, and High and Limb. Thank you guys very much. You guys are incredible. Okay, so for our check data function, this is some pretty basic stuff. I'm going to copy and paste this one in. So I'm just going to stuff this here. And all this does is, again, not the most ideal. You'd probably want to like pass the lists in as parameters to make this like a more utilizable function. But anyways, all it's doing is a block of code that I ended up using twice, so I just threw it in a function. But you'd probably want to improve that a little bit. Again, none of this is going to be very polished stuff. I'm just trying to run through it, find things that work, and keep iterating over. So feel free if you guys want to clean up the code or whatever, have at it. Anyways, all we're going to do is iterate over the lists, get the lengths of all the lists, and then return the lengths of all the lists. So once we've got the lengths of all of these lists, the next thing that we want to do is go with the smallest one. So we're going to say lowest data equals the minimum of those lengths. And then we want to shuffle all of them. So we want to shuffle no attacks because we're about to trim them. So I'm going to copy, paste, paste, paste. Be nice maybe to iterate over the lists rather than doing this, like copy and paste, but change one little thing, like for list and a list of the lists, basically. Do that. Anyway, so we're going to shuffle those. And then what we're going to say is we want all of these lists to be sliced from the beginning to the length of whatever the lowest data is. So again, this would be better if we iterated because then we would also be able to iterate this part. So we're going to say no attacks equals no attacks up to the lowest data amount. So again, this is how we're going to balance all of the data. So if one action has, let's say you got a binary choice, right? You've got a yes or no, and you're going to feed yeses and nos to a neural network. If the yeses and nos are a 50-50 balance, chances are the neural network is likely to figure out the real reasons why you might have a yes or no. If you have yeses that are 80% of your training data is yes, the neural network is instead most likely or more likely to just learn always predict yes. That's a really easy thing to learn. So it's a really quick descent or ascent in whichever way you're going. And that it's just not good, right? So you want to avoid that, and one way you can avoid doing that or falling into that pitfall is if you balance all your data. So again, I'm just going to copy, paste. That was closest to Nexus. Paste. Copy, paste. Okay, so now we're trimming all of the data, and then I just want to check data one more time to make sure it's of the lengths that we intended. So let me go ahead and run that real quick, make sure everything's working before we do the rest. Really? I could have sworn check data printed. It does. What? What would be happening here? Why wouldn't... There's no error. There's just these like TensorFlow keep dims warnings, which is fine. Why did this not... or why... why is it running? And then... doesn't make any sense. So it runs through the epochs no problem. While not maximum. Oh. Okay. I'm pretty sure I meant that. While we have not reached the maximum. But we're going to do that for 10 epochs. So we're doing the slices. Cool. Cool. Okay, so you can already see it's trimming and stuff. What was the deal? X? I don't think that cancels the build, though. Yeah, let's just hit cancel build. Okay. All right, so everything's working up to this point. So now what I want to do is we want to combine all this data. So we're going to say train data, and that's going to be no attacks plus attack closest. It doesn't really matter. We just need all four lists. So attack structures, attack closest to Nexus. Cool. So now we have all the training data. Now we, again, want to random.shuffle the train data. And again, we want to do this because these are pretty long lists. And the way the neural network is going to work is you might start with no attacks, but you're ending on this, like I say, attack closest to nexus. So the last 2,000 samples that the neural network is going to see are going to be all one answer. And that's going to cause problems. So it's going to go through no attacks and then slowly start to always predict no attacks. And then we're going to switch over to attack enemy start. And it's going to only predict that. And it's going to just keep doing that over and over. It's just not a good idea. So we'll do it this way. The next thing is test size. So we're going to set our test size to be 100, and then we're going to set our batch size to be 128. Now we're going to set X train and Y train. I'm going to copy and paste these in. It's kind of arduous to type these out, and it's not really too much point. So somebody, somewhere, help me avoid, what's a man got to do to not have to type? I understand why we have to reshape here, but if I just try to do, let's say I try to do train data and just do a slice of the train data, and like, so for example, if you always want the firsteth, you can do like colon, comma 1, or I can never remember the exact order. I think it's colon comma 1 for always the firsteth element. Anyway, if you try to do that here, it just doesn't work. Why? Why do I have to rebuild the array and then reshape it? There's got to be a better way. So anyways, somebody tell me the better way. Basically, so I can avoid doing this part. This I1 for I in train data to the test size, or through the, never mind. Anyways, so I can avoid doing this. Thank you. So what's going on here is basically what we're really trying to do is we're just saying, okay, the training data for X is always like your input, Y is your target. So X, the input, this is the imagery. This is the picture that we drew in OpenCV of the game map and all our units and colors and sizes. So that's what our X's are, and the Y's are the attack choice that we make. So what we're doing is we're just going to say the training X is all the way up to, or basically keep the last 100, right? The last test size. So up to the last 100 elements. That's our training data. And then the last 100 elements down here for the testing data. And then we just have to reshape them this way. This is just what the models want. That's basically the case if you're passing this to scikit-learn, or you're doing straight raw TensorFlow, or in this case, Keras. Okay, so once we've got that, we're ready to do a model.fit. And to fit, we need xtrain, we need our ytrain, and then we're going to have our batch size equals batch size. The validation underscore data, we'll go with xtest and ytest. And we do want to shuffle, so shuffle equals true. Actually, we probably don't need that. I think we're kind of handling the shuffling and all of that ourselves. Verbose is 1, and callbacks is just going to be that tensor board. So I actually haven't toyed with verbose, but I'm going to wager that that's going to be in conjunction. That's is how much logging that you want to do. I think that's the for straight up tensor board. What kind? It's like at least with the way that we're doing things here, we should be keeping track of accuracy and validation accuracy and loss, like the main things. But you can raise this up and track more things. I'm not 100% on that, but I'm pretty confident that's all that is. After we do the fitment, we're going to go ahead and model.save, and we can save this as whatever we want. And in fact, I'm going to copy and paste this last part because I don't feel like typing that out. And then so all I'm doing is kind of dynamically saving this. I'm saying how many epochs am I doing? What was the learning rate? You could make other things. I'm putting stage 1 just because it's that first model. And then all I'm doing is incrementing our current number where we are. And as long as current is not greater than maximum, we're going to continue moving along. So once it is, boom, we pop out. And if we have more epochs to do, we do more epochs. Again, not the most ideal thing. Also, xtest and ytest, these are not out of sample. because they're random, right? We shuffled every time. So, you might want to separate out your, have some truly out of sample testing. So like the validation accuracy that we're going to get here, take it with a grain of salt, basically. Again, I'm just trying to get answers. Can a model learn with this input? I'm going to run it just to see. The recording may screw up. It doesn't like it because it's going to hog my entire GPU. So as long as it works, I'm going to stop it. But we'll see. It may not work. I hear it. I see it. Okay. So we can see it's training right now. We can look at loss and we can kind of see what's going on. It's going to take a while. So we at least can see losses going down. Accuracy is about 25%. What's 25%? I should probably stop this, actually. I have no idea. I'm probably cutting out at this point. I can see I'm lagging, at least on OBS. Anyways, 25% is if you were to choose all one, right, or anything at random, you would probably have a 25% accuracy. But over time, things get better. So these are just some of the graphs I took from TensorBoard. And I just put them in the text-based version of the tutorial. So initially I just used 6,000 samples. Things weren't really going very good. Then I increased to having about 110,000 samples. And then after some training, I got this, and then this was the loss. But then if I zoomed in really, really far into the loss graph, you can see, oh, it's still sort of going down. So I let it go for a very much longer time, and you can see here basically what happens. It just kind of levels out, and then it starts to fall. So yeah, very interesting. So anyway, here is over a much longer time frame. This was after 30 full epochs, the result. So it definitely can learn. 60% accuracy on 4 choices is actually pretty decent. You would want it to be a little better, but then again, the model and the actual structure of everything is pretty crude here. So 60% accuracy, I'm taking that as a victory. Anyway, full code is in the text-based version of the tutorial if you need it. In the next tutorial, what we're going to be talking about is using the model. So actually using the model is not too hard. We should be able to run through that pretty quickly. And then we're going to talk a little bit about a lot of the problems, at least the ones off the top of my head. I've been taking notes throughout this entire kind of segment now of all the things I kind of want to work on and stuff like that. And that'll be, if you have any suggestions for things you think we should improve, that would be the time. So start thinking about those things. Anyways, if you've got questions, comments, concerns, whatever, you know the deal. Leave them below. Otherwise, I'll see you in the next video.